Is it visible to you, ma? Syllabus?
Yes, sir.
Yes, sir.
Okay, okay. The subject we are going to study is heat transfer this semester. Okay, so this semester, this subject for this particular subject, okay, we'll be having 4 credits, right? That is, we will be having 2 hours practical, that is 1 credit, okay, and we will be having 3 hours theory, right? Tutorial is also very very important. Okay, tutorial has, okay. Um, what I will do is I will be teaching you the theory as well as I'll be doing some problems in the classes. Okay, so there won't be any separate hours for tutorials. Okay, so that's my style actually. Okay, so whenever I'll be teaching theory on the first day, and the next day I will be solving some numerical related to that. Okay, so the first thing is all of you try to get the heat transfer data book by CP Kotanraman. Okay, it will be available in the bookshops. Okay, heat transfer data book by CP Kodanraman. Okay, without the heat transfer data book, it's very difficult for you to see because the formulas, right? Water formulas. We are going to use, okay, we will be taking it from the heat transfer data book. Okay, so there is no need to memorize the formula by heart the formula, right? So just you can use the heat transfer data book by CP Kodanraman, and you can start doing the numerical, which is going to be there in all the modules. And purely this is a analytical paper, okay, numerical subject. Okay, so you have to apply or application of whatever you study, okay, based upon which you will be having problems. Okay, and as far as course objective is concerned, okay, so the main course objective is we are going to discuss about the various modes of heat transfer, right? Conduction, convection, and radiation we will be discussing, and we will be discussing about the how we can give solution for the heat transfer problems which is there in the industry. Okay, so and similarly to equip the student in the design of heat exchanger. Okay, nowadays heat exchanger, wherever you go, whether it is a power plant, okay, thermal power plant, or whether it is a nuclear power plant, okay, or different types of power plants are there, right? Gas turbine power plant, okay, diesel power plant, okay. So the role of heat exchangers is very very important. Okay, and being India a very large country, and it depends so much on especially for power production. Electricity is produced majorly from the steam power plants. Okay, so the role of heat exchangers, okay, and design of heat exchangers is very very important. And all these things you will learn in the due course of time. Is it visible, ma? Is it visible? Am I audible?
Yes, sir.
Yeah. Okay. And similarly, when we talk about the outcome, the basic laws of heat transfer. Okay, uh, there will be Newton's law of cooling, and there will be Fourier law of conduction, and there will be Stephen Boltzmann law of radiation. Okay, there are so many laws. Okay, so the basic laws of heat transfer we will be discussing it. Okay, and we will be solving problems in steady state and steady state, steady state condition, and heat conduction, and transient heat conduction. Transient means and steady state. That's it. Okay, for simple geometries, analyze natural and forced convection heat transfer process, solve radiation heat transfer problems, and similarly design of heat exchangers by 2 methods: log mean temperature difference method, and number of transfer unit method. Okay, NTU method is number of transfer unit. LMTD is log mean temperature difference method. And similarly we have the laboratory, and of course I handle 2 labs also, one on Monday and another one on Thursday. Okay, so even for that lab also I have created MS Teams. Okay, for Thursday's batch I didn't do it. Okay, um, am I speaking fast? Is it audible?
Yes, sir.
Yes, sir.
Can I slow a little bit, or is it okay?
It's
It's
okay,
okay,
sir.
sir.
It's okay, because some of the students they generally say that I'm slightly speaking faster. Because see what happens is when you normally then listen in MS Teams. Okay, sometimes if I speak so fast, then it will be slightly difficult to understand. That's why I'm asking you again and again. And due to the net connectivity issue and all. because if it's a offline class, then it won't be a big issue. Is it fine?
Yes, sir.
Okay, ma'am. So, and similarly, the first module, it is of 2 hours. One is about the basics of conduction, convection, and radiation, the fundamental laws which were related to uh, the heat transfer, the three modes of heat transfer. And in module 2, we will be discussing about Cartesian coordinate, cylinder coordinate, and spherical coordinate. Okay, so especially the conduction, heat conduction, especially in case of a composite wall, composite cylinder, and composite sphere. Okay, so we will be discussing, for example, what is the need for studying about the heat conduction, composite wall, cylinder, and sphere? Any idea, ma? Why we have to study heat conduction? What happens during the daytime? Why why people stay inside the residential building? And during summer, why they use air conditioners? And in European countries or in countries like Canada, why they use heaters during winter? What is the reason? Yeah, this is a practical course here, very much related to our day-to-day life. Heat transfer is a very important subject. What is the reason, ma? Why we use air conditioners and heaters during winters, winter
So
and
due to the
summer?
respective weather conditions in the respective areas,
Yeah.
sir.
Okay. Now, what happens if we don't use the air conditioner? Even we are in a closed room, how we feel the heat?
Sir, will feel very hot, sir.
Yeah.
Will
How? Why?
Sir, because of transfer of heat from the environment to your body.
Yes, transfer of heat from the environment to the body, or surrounding outside temperatures around 38 degrees, or sometimes in places like Bhopal and all, in various places in North India, it will be around 40 to 43 degrees, right? So naturally, the heat is conducted. The surrounding temperature is heat is transferred to the wall, and from the wall, it is transferred to the inner space. Am I correct? Am I correct?
Yes, sir.
Okay, so that's why we will be studying a composite wall, okay, where how the heat is transferred from outside to inside, or from high temperature layer outside to low temperature layer inside, or in some cases, for example, if you have a hot pipe, or if you have a pipe which carries a hot fluid, for example, steam. Okay, in case of in case of steam turbines, what we have the steam which impinges on the turbine blades. Am I correct, students?
Yes, sir.
Now the steam will be carried, that is the steam will be flowing through a pipe. Okay, the pipe will be insulated. Okay, the reason for insulation is the insulation doesn't allow the heat uh, possessed by the fluid to transfer to the surrounding atmosphere. Why it is so? Because usually steam, the boiling point of steam at atmospheric pressure is 100 degrees C, and for high pressure steam it will be around 300 degrees C or 400 degrees, 370 degrees C, maximum critical temperature. Okay, 374 degrees C. Okay, so if the steam flows at a high temperature inside the tube, okay, then if it is exposed to the surrounding atmosphere, which is at 20 degrees or 30 degrees, then naturally the heat transfer takes place from the high temperature body to the low temperature body. That's what we studied in second law of thermodynamics. What second law of thermodynamics says? Heat can be transferred from a high temperature body to a low temperature body without any work aid. And if we want to transfer heat from a low temperature body to high temperature body, then we need special devices like pumps. Okay, pumps or refrigerators, which maintains a body at a lesser temperature than that of the surrounding. Okay, am I correct or not?
Yes, sir.
Okay, so for that, okay, so for a pipe which carries hot steam, okay, we have to properly insulate it, or otherwise, what happens is the temperature of the steam will reduce, and when the steam impinges on the turbine blades, the temperature will be lesser, or there might be a condensation also, right? So if it gets condensed, then what happens is it causes corrosion of the turbine blades. Okay, so to overcome that we have to discuss about composite cylinders, composite spheres, composite wall, etc. in the conductive heat transfer or conduction heat transfer. That's what it was mentioned here. Conduction in composite walls and shells. Okay, and similarly the critical thickness of insulation. Okay, so what is insulation? The insulation is usually provided to reduce the heat transfer from inner to outer. Okay, and for as I mentioned earlier, for hot tubes which carry steam or hot water, okay, the outside heat should not be transferred. But what happens in case of wires and all, electric wires? During summer, we used to see bursting of the electric cables, especially in transformers. Why it happened, ma? Any idea? Why it happened? All of your engineers, are you there? How many
Yes, sir.
students are there? What happens, man? Why the cables burst, ma? Any idea? Burst out?
The surrounding
Because
temperature
of
is also
thermal
high, and
expansion.
due to resistivity, there will be increasing temperature. Both combined, puts thermal stress, and since the insulation will expand, it will burst.
Yes. See, what happens is the heat. Whenever a conductor conducts, there will be uh, internal heat generation. Okay, there will be internal heat generation that we will be discussing in the internal heat generation in plane wall cylinder and sphere. Due to this internal heat generation, what happens is if you don't have the critical thickness of insulation, the critical thickness of insulation is the thickness at which the maximum heat transfer from the copper wire to the surrounding atmosphere takes place. Okay, the maximum thickness at which what's that? The heat transfer from the copper wire to usually copper wire is it is insulated with plastic, right? Have you seen that even the cable wires which we use in our houses, it is insulated by the insulator. Okay, so that what happens is even when we touch it, okay, we won't get the shock. Okay, unless otherwise if the copper wire slightly protrudes out somewhere, we will be getting the shock. Okay, or otherwise we won't get the shock. Okay, so what happens is due to the flow of electricity, the heat will be generated. That internal heat generation generated has to be dissipated out. Okay, so if it is not properly dissipated, as some of your friends said, okay, during summer the outside temperature is also higher, and due to improper heat dissipation during summer, what happens is usually the cables burst out. Okay, so the concept of critical thickness of insulation, which is there in module 1, sorry, module 2, we will be discussing it, and we will be doing small numericals in it also. And similarly, internal heat generation in walls, cylinders, and spheres, we will be doing it. And in module 3, we will be discussing about conduction shape factor. We will be discussing about lumped heat systems, and we will be discussing about infinite bodies, flat plates, cylinder, and sphere, semi-infinite bodies, etc. We will be using some charts known as Haisler charts. That's why I said see, when you come for Friday's class, tomorrow I will be having introduction about basic modes of conduction, convection, and radiation. But when you come for Friday's class, I want all of you before this weekend or during this weekend, I want all of you to buy the heat and transfer data book by CP Kodandraman. Okay, without which you will not be able to solve. And similarly, when you come for the class, okay, when you come for the class, offline class, okay, during the next 2 weeks, okay, after next 2 weeks, okay, you have to bring this. Without this data book, we will not be able to solve numericals in all the modules. Okay, so in case of lumped heat capacity system, okay, which is again it comes under unsteady state heat transfer, right? In case of unsteady state heat transfer, why we say unsteady state heat transfer? All of a sudden, when you drop a solid to a fluid which is at a high temperature or less temperature, we will be having unsteady state heat transfer. See, heat treatment process, all the heat treatment process were unsteady state. Am I correct or not? See the coil springs, okay, especially rails. When you look into rails, okay, the rails will be using the coil springs. The coil spring will be very heavier. Okay, so what happens is all of a sudden after taking the coil springs from the furnace, immediately they will drop it in chill water. Okay, the purpose of dropping it in chill water is to increase the strength of the particular material or the particular coil spring. Okay, so the lumpy heat capacity analysis deals with dropping a solid which is at a very high temperature into a fluid which is at a lesser temperature, or sometimes dropping a solid which is at a lesser temperature into the furnace which it will be at a higher temperature. For example, cooking of food. Okay, especially the nowadays we use the what's that uh, what's that OTG, what it mean actually, you do all the things, right? You will be see, usually the food will be at a room temperature of around 30-35 degrees. Okay, especially in grill and all, we will be placing it and we will be heating the food, and we will be taking it out. Okay, and we will be setting the time also. So in food industry, especially it is used. Okay, especially the heat transfer concept is very much used. Okay, in food industry. Okay, and when we talk about module 4, we will be having convection. Okay, convection is again mode of heat transfer which occurs between a body and a fluid. Okay, and again here we will be discussing about flow over flat plate. Okay, forced convection and natural convection. Can anybody say a very practical example of forced convection and natural convection, ma? Day to day life example, forced convection and natural convection. Anyone? Am I audible? Am I audible here?
In cars, we have radiators as well.
In cars here? Natural convection, radiators. Okay, fine. Day to day life. Can you drink coffee, Charles?
Sorry, sir.
Can you drink coffee or tea the morning?
Yes, sir. Yes, sir.
Okay. Whether you drink as it is,
No, sir.
when you, what you will
Either we
do?
blow on it or
We will be
pour it
transferring the
up and
fluid.
down. Yeah.
We will be transferring the fluid from one tumbler to another tumbler. So we will be imparting some more motion to the fluid. Okay, so that the heat is transferred from the hot fluid, that is hot coffee, to the surrounding air. Right? Am I correct or not?
Yes, sir.
We will be transferring the fluid, that is the coffee, from one tumbler to another tumbler, so that your velocity is imparted to the hot coffee or hot fluid, so that what happens is heat is transferred from faster from the hot fluid to the surrounding air. Okay, when you keep the tumbler as it is without transferring the fluid, slowly slowly it cools down. Am I correct or not? When you impart
Sir.
motion
Yes.
to the fluid, the heat transfer occurs fast and it cools down fastly. But when you keep the tumbler as it is, after some time the temperature reduces. Okay, but it happens slowly. Okay, so in case of natural convection, what happens is, okay, the hot body is in contact with the surrounding air which is at a lesser temperature, so that what happens is, when at the surface of the hot body, when the cold fluid, when it touches, what happens is there will be that is uh, reduction in density. Okay, what happens is, due to this less density, what happens is the natural buoyancy occurs. Okay, so that what happens is the air movement is created and the air moves up and the chill air comes in contact, but it happens slowly. Whereas in case of forced convection, you can either force, right, you can either force, okay, the hot fluid, or you can in case of what happens in case of um, radiators, as you mentioned. Okay, in case of car radiators, okay, the engine will be hot. Okay, so a small pump will be pumping the water into the engine gaskets. Okay, so that cooling water jackets. Okay, cooling water jackets, so that cooling water will be flowing through, flowing over the engine cylinder, and it will take the heat energy. Okay, so forcing water, right? Forcing water and taking the heat energy is an example for forced circulation, whereas having the radiator, car radiator at the front, and having fins and all. It's an example for having natural convection as well as conduction. Okay, a combo of convection and conduction will be there in case of radiators, car radiators. Okay, so the surrounding atmospheric air, it will be taking the heat energy from the fin material or the radiator material, and slowly the engine gets cooled. Okay, so forced convection as well as natural convection will be there in case of car radiators. Okay, so we will be discussing about it. We will be discussing about flat plate, uh, flow over flat plate, flow over cylinder, spheres, and bank of tubes. Especially in case of heat exchangers, we will be having so many tubes. Okay, in thermal engineering systems or in power plant engineering, you might have studied about fire tube boiler and water tube boiler. What happens in case of fire tube boiler and water tube boiler, ma? Anyone? What happens in case of fire tube boiler and water tube boiler? Any idea? Because the applications of heat transfer will be there in thermal engineering systems as well as power plant engineering. What is fire tube boiler? What is water tube boiler? Ma, anyone? Yes, students.
Sir, in fire tube boiler, hot steam is used to heat the water in the pipes. So,
Okay, very good. Hot steam or hot gases? Hot gases will be
hot
flowing
gases.
through the tubes, and you will be having uh, you will be having cold fluid surrounding it. Am I correct? See, the Lancashire boiler is an example for the fire tube boiler where the hot gases, you can see that at the center, the hot gases will be flowing, and the tube will be surrounded by cooling water. Okay, so the heat is transferred from the hot gas to the tube material and from the tube material to the surrounding cold water. Okay, whereas in case of water tube boilers, what happens is you can see here the water will be passing through the tubes. Is it visible?
Yes, sir.
Yes.
The water will be passing through the tubes and the hot gas will be surrounded. Okay, so these are all some of the examples of fire tube boilers and water tube boilers. In addition to that, we will be having the application we will be having in nuclear power plants also. Okay, in diesel engine plant, in heat transfer plant, sorry, gas turbine plant, etc. Okay, we will be having the application of this. You can see here the you will be having a steam generator, you will be having a turbine, you will be having a condenser. Okay, so the condenser is again a heat exchanger, so steam generator is a heat exchanger, and similarly the reactor vessel. All of you are able to see the animation.
Yes, sir.
So the basic concepts of heat transfer, right? The basic concepts of heat transfer is extensively used in steam power plant, gas turbine power plant, diesel engine power plant, nuclear power plant, etc. Okay, so the heat is transferred from the heat which we get by means of fission is transferred to the coolant material. You can see here the red color one is the coolant material. The coolant material gives this heat energy to the water. Water is in blue color. Slowly, what happens is water becomes steam. The steam flows and it impinges on the turbine blades. Okay, so when the turbine blades start rotating, it automatically rotates the generator. So that what happens is we will be getting the electricity, and then the low pressure steam flows over the condenser tubes. Okay, so there are two cases. Okay, the hot in case of steam generator, the hot coolant is flowing inside and it gives its heat energy to the circulating water. So water becomes steam. The steam flows and impinges on the turbine, and what happens is the turbine runs the generator and you will be getting the electric power. Okay, and then the low pressure steam, it passes over the condenser tubes, and when it passes over the condenser tubes, inside the condenser tube you will be having the cold fluid. Okay, so inside the reactor you will be having the hot coolant which is transferring heat to the water, whereas here inside the condenser you will be having the water which will be the cold fluid which will be converting the low pressure steam into liquid again, and then the liquid with the help of the pump again it is pumped into the steam generator. So this is a continuous process, or this is a continuous cycle. Okay, so the use of this. Okay, This is what we will be discussing in bank of tubes. Okay, bank of tubes often we use in boilers, which is used in steam power plants. Okay, and internal flow. Okay, the flow inside a tube. Okay, flow inside a tube. We will be discussing boundary layer concepts. We will be discussing about Reynolds number, critical Reynolds number, and Grashof number. Okay, so in case of natural convection, we will be using Grashof number, and in case of forced convection, we will be using Reynolds number. Okay, so Reynolds number and Grashof number will be using. We will be using. Okay, and there is one more number which is said to be Rayleigh number, which is a product of Grashof number and Prandtl number, GRPR. Okay, so we will be discussing about the dimensionless numbers also in the classes, especially before we start convection. We will be discussing about it. Okay, and similarly, the concepts of boiling and condensation also we will be discussing in module 5. Okay, so that's why the heat transfer subject is very very important. Okay, the heat transfer subject is very very important. Without this basic knowledge of conduction, convection, radiation, you will not be able to design heat exchangers. You will not be able to work in power plants. Okay, the basic knowledge of heat transfer is very very important when you want to work in power plants. Okay, and similarly radiation, when we talk about radiation, we will be discussing about the basic terminologies. As I mentioned earlier, we will be discussing about Wayne displacement law, Stephen Boltzmann law, okay, etc., and we will be discussing about what is white body, what is black body, what is gray body, etc. Okay, and similarly what is a real surface and electrical analogy, all those things we will be discussing. Okay, we will be discussing about what is emissivity, what is reflectivity, what is observability, what is black body, what is white body, what is gray body. Why the cricketers wear white, ma, during test matches? I'm not talking about the colorful ODIs or T20 which nowadays they play. I'm talking
So
about the
the
age
heat,
old test cricket.
Sir,
so
it
the heat
reflects
is
all
less
the
in white.
radiation, sir. So the
Yeah,
heat is.
white is a substance, or white is a color, or white body is the one which reflects all the radiation impinge on it or falls on when all the radiation when it falls on the white body. What is black body, ma? The black body is the one which is capable of absorbing all the radiation on it. Okay, so especially for solar heating, we can see the black color. Okay, solar panels. Okay, we will be using small tubes, but will also see the solar panels coated black in color. The reason being is it absorbs all the radiation, so that what happens is you will be having more heat. That heat is transferred for to the water which will be circulating. So for water heating purposes, they will be using solar panels. Okay, and nowadays for producing electricity also we use solar panels. Okay, so that is one of the important technique which we can use for producing electricity, at least to run a run a fan, light, television set, etc. nowadays. Okay, especially in villages and all, they use this solar panels to at least light a tube light and to provide electricity. They get electricity and they use it for lighting a light, fan, etc., or television set, etc. Okay, so we will be discussing about reflectivity, observability, emissivity, transmissivity, etc. in in this radiation. And finally, the last module deals with practical applications. That is, it will be dealing with fins, heat exchangers, and radiation shields. Okay, and in between, you will be having one guest lecture from an industrial expert for this heat transfer subject. In addition to that, let me show you. So as far as textbook is concerned, okay, as far as textbook is concerned, okay, yeah, as far as textbook is concerned, you will be using two textbooks. One is Yunus Angel, the other one is Sachdeva. Sachdeva is a very good textbook, ma. You can refer it, and It's available in our lab library also. Okay, it's a very good textbook. Okay, or you can refer the heat transfer by Rajput also, heat and mass transfer by R.K. Rajput. That's also a very good textbook, especially Rajput. It has solved so many examples. Okay, numericals will be more, whereas in case of Sachdeva, the numericals will be less. In case of Jonas Senjal, the numericals will be lesser. Whereas in case of Rajput, we have so many number of problems. So you can refer these three textbooks. Okay, Sachdeva, Rajput as well as Senjal. Okay, if I have any soft copy also, I will try to upload. And similarly, laboratory also, you know that. And yeah, one more thing I wanted to say. Yeah, this is the course plan. Okay, the first 2 hours we will be discussing about introduction and uh, that is principles of conduction, convection, radiation. I will be covering, and module 2 I will be starting during this Friday. Okay, and one-dimensional heat transfer, numerical problems, and composite wall, critical radius of insulation, critical thickness of insulation, and numerical problems in one-dimensional steady state heat generation we will be discussing in module 2. So it will be I will be taking 8 hours for that, so 8 plus 2 10 hours. Okay, and in module 3 we will be having conduction shape factor and unsteady state heat transfer. Okay, so for your cat 1, the first 3 modules will be there. Okay, for cat 1, yeah, the portions for cat 1 is module 1, module 2, and module 3, whatever I cover up to in module 3, it will be there. And for cat 2, module 4 and module 5 and module 6. Is it visible?
Yes, sir.
Is it visible, ma? Everyone?
Yes, sir.
And for fat, all modules will be there, right from module 1 to module 8. Okay, and similarly the portion for cat 1 is we will be having 4 questions, two 10-mark questions and two 15-mark questions. And similarly the same is followed for cat 2 also. Okay, and suppose if it is a offline examination we will be following it. Okay, if it is online then we will change it. Okay, and similarly digital assignment. Okay, we will be having 3 digital assignments. The first two will be numericals. Okay, and the third one will be in the form of a short video lecture, duration of 5 to 10 minutes. And the guest lecture, as far as guest lecture is also concerned, we will be identifying some persons and we will be getting it to you. And the percentage evaluation burden, cat 1 is 15 percentage weightage. We know that cat 2 is 15 percentage weightage, and digital assignment is 30 percentage, and final flat exam is 40 percentage. Okay, you know that. So these are all the things which I wanted to say you. And as far as the textbook is concerned, that's what I said. The textbook is, you can go for Sasdeva. That is a very good book, or you can go for Rajput, or you can go for Senjal. Okay, these 3 textbooks you can follow for the heat transfer. Okay, and the cat also I told you, and similarly the lesson plan also I told you. What I will do is post this lesson plan. Okay, and syllabus after this class I will be posting it in uh, in the in the MS Teams itself. Is it fine? So all of you,
Yes,
please,
sir.
please try to have calculators with you during the class. Okay, it's very important. Okay, so and again, this is an application-oriented subject. Okay, so you are supposed to attend it carefully, attend all the classes. Okay, and yeah, these things we will be discussing tomorrow. Okay, where we will be using this applications of e-transfer, right? The application of e-transfer will be in air conditioners, refrigerators, power plants, car radiators, circuit tubes. Okay, in air conditioners where we use this concept of heat transfer. Anyone? All of you studied refrigeration and air conditioning in thermal engineering systems. See, whatever we studied earlier, the extension of what we studied in thermal engineering systems, we will be discussing it here. Yeah,
Condenser and evaporators.
evaporator and condenser. Very good. That's a very good answer. In case of air conditioner, we will be having both evaporator as well as condenser. Okay, and similarly in refrigerator also, we will be having evaporator and condenser. And due to the heat transfer, right, or due to the leakage of the refrigerant. Sometimes what we will be having is after 2 or 3 years we have to again refill the refrigerant. Okay, so normally the person who comes for who comes for repair works of this air conditioners and refrigerators, they used to say gas filling. Actually it's not gas filling, ma, it's the refrigerant filling. Okay, so they are filling the refrigerant. Okay, as mechanical engineers, please hereafter please say that they are not filling gases. Okay, they are filling the refrigerant. Okay, the refrigerant, it will be having very low melting and boiling point. That's why it is in the form of gas. Okay, so all of you please don't say that gas filling. Okay, and different type of refrigerant will be used. Okay, dichloro difluoromethane, R12, R22, and R134, YF 134, YF or 134A. Okay, all those are refrigerant 134A. Okay, different types of refrigerants were used, and similarly in power plants. This is what I was mentioning, right? Without the knowledge of heat transfer, we will not be able to work in power plants, whether it is a steam power plant or nuclear power plant, okay, or gas turbine power plant or diesel engine power plant. Without the knowledge of heat transfer, we can't work. Similarly, in case of car radiators, we have this. We have the uh, yeah, whatever energy systems we have. Okay, whether it is a that is a solar engineering. Okay, so, when we talk about solar power plants, or when we talk about unconventional power plants, right? Uh, we have to study the concept of heat transfer. Okay, it's very very important. Even circuit boards. Okay, especially in case of television sets, laptops, etc. Why the fan is there in the laptop? Okay, a small fan will be there. What is the reason for providing that small fan? Anyone?
To dissipate the heat from the
To
laptop, the
dissipate the
processor.
heat, from the motherboard, or otherwise what happens is if the motherboard gets heated up, then what happens is automatically there will be some fusion of some wires will be there. The circuit board won't work properly. Okay, and we have to throw away the circuit board. Okay, so these are all some of the common heat transfer applications. Apart from it, the modern day life, food industry, am I correct or not? Nowadays, that's what I said. Nowadays, we go for OTG, right? Oven, right? Ovens. Nowadays, you people, you are very much interested in having that type of food, right? In food industry, the application of heat transfer is very very important. Okay, so we the internal heat generation inside a solid is very very important. Okay, so we will be discussing all those things. Okay, so practically you see that's the role of engineers. Okay, whatever theory you study, try to apply it practically uh, to the daily usage. The usage of pressure cookers, again, pressure cooker is a very important one, which uses the concept of thermodynamics, which uses the concept of heat transfer. Okay, so that you can cook faster, right? So these things are very very important. Okay, and we will be discussing about all these things in this semester, especially about how we apply or how we use this concept of heat transfer to the various devices. Okay, so with this I stop for the day. I will stop the recording. Actually, I'll stop the recording. If you have any question, you can ask me.